Alright, 7.2, solving trigonometric equations algebraically. So this one requires a little bit more math than the graphically, which was just typing it into Desmos. Okay, so use algebra to solve the equation the root of 2 sine x minus 3 equals negative 2 for negative 360 is less than x less than 0, and then write the general solution. So first of all, let's start with the equation. We are going to isolate. So we're going to go add 3. So we have the root of 2 sine x equals, this is a negative 2. So it'd be 1. And then we're going to divide by root 2. So we know sine of x equals 1 over root 2. And because sine is positive, it's going to be in quadrant 1, or it's going to be in quadrant 2 because all strippers take cash. So 1 or 2. We'll use cast there. So we can do now sine to the minus 1 of 1 over root 2 will give us what our angle is, or because it's 1 over root 2, I can know that I can use my unit circle to know that my answer for sine of 1 over root 2 is 45 degrees in quadrant 1, and it is 135 degrees in quadrant 2. So we know that our reference angle is 45 degrees. So that'll help us solve this. So we know it's here or here. The only thing that we have to take into consideration here is we're dealing with negative 360 to 0. So we're not actually looking for 45 degrees. We're looking for this angle and this angle. So it's not going to be 45 degrees. It's going to be negative 360 plus 45 degrees. So it's going to be negative 315. So that would be this angle right here. And it's also going to be negative 180 plus 45. Or minus 45 plus another negative 45. And it will be negative 225. And that's this angle right here. So those are my solutions, 315 and 225, negative 315 and negative 225. Our general solutions. So we're going to take each of those intercepts. So it could be x equals negative 315 degrees plus, now we need to know what the period of this function is. So looking at this, it has not been manipulated in any way for my b value. So it has a period of 360 degrees. So we're going to go 360 degrees times k, where k is some integer. And we can also do it from negative 225. So we'll have intercepts at negative 225 plus 360 degrees times k, for k to be some integer. Okay, example 2. Use algebra to determine the general solution for the equation cos 3x equals negative 1 over 2. So because cos is negative, that means that we are going to be, it can't be here or here, so it has to be in quadrant 2 or quadrant 3. That's where we're dealing with. So we're going to find the reference angle just the same as we would if there wasn't a 3 there. We just pretend it's not there. So I would do cos to the negative 1 of 1/2. We don't have to worry about the negatives or anything because we're just going to use the unit circle. So looking on my unit circle, I want cos to be 1/2. That's going to be right here. So my angle that I want is 60 degrees. Oh, we are dealing with radians, so we are dealing with pi over 3. So our reference angle is pi over 3. And we're going from, that's supposed to say negative pi to pi. Let me bring up the unit circle again. Actually, we don't need it. So that means that we're going from we can have it in this quadrant because it's in quadrant 3. So from negative pi to pi is that circle. So I'm going to be able to get, in this quadrant, I'll be able to get from here to here. That's the angle I'm going to be able to see from negative pi to pi. Actually, I guess we just do this one. Let's do that angle. That's the angle that makes sense. So that's our first angle. And then the other angle we'll get, so this is pi over 3 as our reference angle. The other angle that we'll get is down here. So this is also pi over 3. So I would get we're not going to be able to get this angle, and the reason we're not going to be able to get that angle is because that's bigger than pi, but we will be able to find this angle. And so those are the two angles that we're going to be able to find. And same with this one, we're not going to be able to find this angle right here because that's bigger than negative pi. So those are the two angles we're going to be able to find. So we can know that if this reference angle is pi over 3, the rest of this angle is 2 pi over 3. Because together they need to make 3 pi over 3. And similarly for this one, if that's pi over 3, this is negative 2 pi over 3. Okay, and because we have cos to be 3x, we're going to set this up as 3x equals 2 pi over 3, and 3x equals negative 2 pi over 3. And then we'll divide by 3, so we have x is equal to 2 pi over 9, and divide by 3, and x is equal to negative 2 pi over 9. So those are our two solutions for this. So we want to come up with a solution, a general solution. So first we need to find the period length of this function. So we do have a 3 in front of the x. So a normal period for a cosine function is 2 pi, and we divide it by our value in front of it, which is 3, so our period is 2 pi over 3. So our general solutions are going to be x equals 2 pi over 9 plus 2 pi over 3 times k, where k is an element of the integers, or it could be negative 2 pi over 9 plus 2 pi over 3k, where k is an element of the integers. Alright, example 2. To the nearest hundredth, solve the equation cos x minus 6 equals 4 cos x minus 4. So I'm going to write that out. Cos x minus 6 equals 4 cos x minus 4. So I'm going to put the numbers on one side and I'm going to subtract the cos to the other side. So I have negative 3 cos x is equal to 2. Negative 4 plus 6 is 2. And I'm going to divide by negative 3, so I have cos x equals negative 2 over 3. I know that this is going to lie in quadrants 2 and 4. That's quadrant 3. Oh my gosh. Because that is where cos will be negative. And I'm going to have a reference angle of 2/3. So I'm going to type in cos to the minus 1. I'm just going to do 2/3 so I can find my reference angle. So if I type in that, I should get 0.84. So that's going to give us that is 0.84 and that is 0.84. So in quadrant 2, my angle is going to be pi subtract 0.84, and I would get 2.3. And in quadrant 3, it's going to be pi plus 0.84, and I would get 3.98. So those are my two solutions. So looking at this, my period for this function is 2 pi, and the reason I know it's 2 pi is because there's nothing in front of these x's. It's just a 1x. So it's a normal period. So to find my general solution, I'm going to take my intercept, so 2.3, and add 2 pi k, where k is an integer. And then we're going to do 0.84 plus 2 pi k, where k is an integer. Okay, we're going to do the next one. So it's the square root, I don't want orange, square root of 2 cosecant x equals negative 5. So we're going to get cosecant x by itself. So we have cosecant, x is equal to negative 5 over root 2. And we know that cosecant x is the same as 1 over sine. So what I'm going to do is I'm just going to flip everything. So I'm going to say sine x is equal to root 2 over negative 5. So looking at our unit circle, we're going from negative 180 to positive 180. So we're going like this. That is the domain we are looking at. And we are doing sine to be negative, so that can be in quadrant 3 or it can be in quadrant 4. So we're going to do, let's go sine to the minus 1 of root 2 over 5. That'll get us our reference angle. Anytime you do it without that negative sign, it's going to get you your reference angle. So if I go second function sine of root 2 divided by 5, I get, oh, we're doing degrees. So make sure your calculator is in degrees, because I just typed it into my calculator in radians and was confused. You should get 16 degrees. So always look at this domain, and that's going to tell you what setting your calculator should be in. So we have 16 degrees. So in this quadrant, we can have this negative 16. And in this quadrant, we could also have this negative 16. So we could go from here to here and from here to here. And we're not going to be able to go from here to here because that's outside of my domain. It's going to be greater than 180 degrees. So we can only do our negative answers for this one. So in quadrant 3, it's going to be negative 180 minus negative 16 degrees. So that's plus. So I would get negative 164. So that's this one. Oops, that's not where I wrote it. And in quadrant 4, it's just my reference angle, so negative 16. Our period for this function is just a normal sine function, so my period is 360 degrees. So to do my general solution, we can say negative 164 plus 360 degrees times k for any integer, or we can do negative 16 degrees plus 360 degrees times k for any integer. And there's our general solution. All right, next one. Use algebra to solve the following equation. So we have 2 cos squared x equals 1. So very similar to what we've been doing, we're going to get 2 by itself, or get that cos squared x by itself. So we have 1 over 2, and now we're going to have to square root that because it's a squared. So we have cos x equals plus or minus the square root of 1 over the square root of 2. So we have cos x equals plus or minus 1 over root 2. And we're going to be going from 0 to 360 degrees. So this is going to be a lot of options. Let me get out that unit circle. So cos of pi over 2 is right here. It's 45 degrees. And because it can be plus or minus, it's going to be all of these. So our answer is x can be 45 degrees. It can be 135. It can be 225. And it can be 315. So that is our answer. So that's our using that unit circle. Okay, last one. I swear. Use algebra to solve the equation cos x minus equals 1 minus 3 cos squared x. So because I have a cos squared and I have a cos, this is going to be a trinomial, and we're going to have to factor. So we're going to move everything to one side. So I'm going to move it to the other side. And minus 1. So we have 3 cos squared x plus cos x, subtract 1 equals 0. And this actually can't factor. So in order to solve this one, we are going to have to use my favorite equation of all time, the quadratic equation. So you have negative b plus or minus the square root of a b squared minus 4ac all over 2a. Okay, so we have negative 1 plus or minus negative 1 squared minus 4 times negative 3 times 1 all over 2 times negative 3. This is going to simplify to be 1 plus or minus the square root of 13 over negative 6. So this means that we can have cos x to equal positive 1, so 1 plus the square root of 13 over 6, or we can have cos x to equal 1 minus the square root of 13 over negative 6. So if I type these into my calculator, we're going to go cos to the minus 1 of this and cos to the minus 1 of this, and we're dealing with radians. So go ahead and type this into your calculator. You should get 2.445 ... and you should get 1.121. So those are our two reference angles. We are dealing with from negative pi to pi. So our period for this is still going to be 2 pi. Because there's no number in front of the x there. Even though it's squared, we don't have it stretched or compressed. So our general solutions, because we can go from the plus and the minus of pi, is going to be plus or minus 2.445 plus 2 pi k, for k is an element of z. Same thing here, we're going to have plus or minus 1.121 plus 2 pi k, for k is an element of z. Alright, and that is how you solve them algebraically. Now let's get on to the proofs.